We've spent the last couple lessons talking about how to graph sine and cosine, learning those as new parent functions. We're going to do the same thing with tangent. Tangent is very different from sine and cosine. Sine and cosine were both those waves and those curves. Tangent, you're going to see, is very different graph. We really don't use tangent as often, and so as you'll see, we're going to do fewer transformations and practice with it just because it's not quite as applicable in real life as compared to sine and cosine. But we still want to take a look at it. So we're going to start by thinking about a circle with an origin, circle at the origin with radius r, and I've kind of drawn a point xy that's on the graph somewhere. So what I'm going to do is make a little triangle out of this. Okay. So what this is telling us is that we are, this distance is x, and this distance is y, because that gets us to the point xy. And then we have this angle theta that we've created. So if we want to find the cosine of theta, that's just adjacent over hypotenuse, which is x over r. Sine is going to be opposite over hypotenuse, so y over r. And tangent is going to be opposite over adjacent, so y over x. Now, I want to show you something else kind of interesting. Let's say instead of a radius r, that the radius was just 1. Okay, it's a unit circle. So instead of x over r, we have x over 1, which of course is just x. Instead of y over r, we have y over 1, which of course is just y. So the cosine theta is going to be the x-coordinate. Cosine is the x-coordinate. The sine of theta is the y-coordinate. And then the tangent is y over x. Now, we're talking about tangent today. So we want to think about, will the tangent function ever be undefined? Well, sure it will. The tangent function is going to be undefined if you divide by 0. So it'll be undefined if x is 0. Well, where does x equal 0? Well, on our circle, x is 0 here, 0.01, and also down here at the point 0, -1. Okay, so that means we're undefined if x equals 0, which happens at, let's see, up here, that was 90 degrees and 270 degrees. And remember, this is going to happen every time around the circle too. So it keeps happening, and it happens in the other direction too. Okay, it's going to happen at -90 degrees and -270 degrees and so on. Okay, so there's tons of places where the tangent function is going to be undefined. What that means for the graph of tangent is when you have things that are undefined, those are going to be vertical asymptotes. So that's why the tangent function looks so different, is that it has asymptotes. It's not a straight curve. Now, going back up to this, remember that tangent we said was y over x? Well, remember y is the sine and x is the cosine. So for any real number, tangent theta is sine of theta divided by cosine of theta, as long as you're not dividing by 0. So as long as the cosine of theta is not 0, that should say is not 0. Okay. All right, so we want to actually graph this using what we just found out. Okay, we know that we can't have this equal to 0, the denominator equal to 0, and that happens at 90 and 270 and -90 and -270. So that means we are going to have asymptotes here and here, and at -90 and at -270. Okay. My dog is sitting next to me, and she's apparently unhappy about tangents. Sorry about that. All right, so now we want to plug in some points. We want to plug in 0. So the tangent of 0 actually turns out to be 0. And you can plug in some more points, but basically I want to show you what's going to happen. Like if you plug in 45, the tangent of 45 degrees is 1, and the tangent of negative 45 degrees is negative 1. And what happens is you get this, I like to call it seaweed, this seaweed looking thing. And the same thing is going to happen here. You get the seaweed thing here and here. So that is the graph of tangent. Let's start looking at some of the things about it. The domain is not all real numbers. It is all real numbers except 90 degrees, 270 degrees, so on, and the opposite direction, negative 90, and so on. Another way we can write this is 90 plus, do you see that this happens every 180? Every 180 n. Okay, so if you add 180 however many times to this. I'm gonna let the dog outside so she quits barking. I'll be back. All right, now the range of this we can do. It is all real numbers, okay, because this keeps going on and on forever. The asymptotes happen at 90 and 270 and negative 90 and negative 270, so they keep happening in both directions. Another way you can write this is the asymptotes happen, let's see, the first one's at 90, and then they happen every 180 degrees. So we say plus 180 n. And the period, remember, is how long it takes to get through one full cycle. So the period of this is going to be 180, or if we're in radians, it's going to be pi. This is different than sine and cosine. Sine and cosine, remember, we're 360, or 2 pi. And then the center point, that first center point happens at 0, 0, and the center points happen every 180 degrees. Okay. We'll talk about some transformations in the next video.